Let's review exponential notation prior to jumping into product and quotient rule. This variable that is being raised to the power of a is what we refer to as the base. And the power, or what we typically call the exponent, is the number or variable to which the base is being raised to. Together, that's exponential notation. So let's begin. Our product rule is going to begin by understanding b squared times b to the third power. Recognize that a power simply means to write it down, in this case twice. B cubed means take the same b, multiply it by itself 3 times. Very important when we were using our product rule. The same base must be present in order for you to use the rule, which is, if I write it that many times, I am simply adding my exponents. So, as long as you have the same base and you're multiplying with exponents, add your exponents. Take a look at the following example when it gets a little harder. 6x to the fourth times y to the third multiplied by 5x squared times y. That is the same thing as if you were multiplying these individual terms. Sums are just numbers, like 6 and 5, and the other exponential notations have different bases. So the ones that go together, the x's, and the ones that are the other bases that are the same are the y's. When you are multiplying, it doesn't change the fact that you're still multiplying 6 times 5, which is 30. Just remember that the product rule has to do with bases and exponents. So let's multiply our x's. X to the fourth times x squared is going to be x to the sixth power. Y third times y to the first power is y to the fourth. So a quick little reminder, when your exponent is not shown, it is a 1. Now let's move on to our quotient rule. B to the fifth divided by b squared is the same thing as creating a fraction bar and writing the same base as many times as the exponent is shown, in this case 5. On the bottom we have 2, and we have learned that when we divide by the same number, it will divide out to the number 1. So when we cancel out the common b's that we see on the top and on the bottom, we have a remainder. And so our quotient rule is take the top exponent, subtract the bottom, and it will tell us what we're left with, which makes sense. Right at the top in our numerator, we see that we have b to the third power. So look at this example where we have a quotient of exponential notations, expressions, and in this case, these numbers that you're seeing in the front are what we call coefficients. 4/12 is the same thing as a quotient of 4 divided by 12. You can simply reduce your fraction and then take a look at your common bases. So x to the fifth divided by x, we're going to subtract our exponents, 5 minus 1, and we're left with 4. Can you take a look at what's going to happen with your y's? Great, y to the sixth. When we have a coefficient that's a 1, we don't typically write it down, so the expression x to the fourth, y to the sixth over the third power is the simplification of this exponential expression. Now take a look at the following expression. Would you be able to reduce or simplify b to the seventh over m to the seventh? So not trying to trick, but to remind you, they are not the same base. So there is nothing that we can do that is as simplified as it can get. So be careful and make sure that the first thing you're going to do is take a look at your bases before you use either product or quotient rule. Finally, take a look at this expression. B third, in this case, now there's fewer common bases of b's, whereas on the bottom in the denominator, we have 5. So when we try to subtract 3 and 5, take a look at, you're still canceling common b's, but the leftover is now in your denominator. When nothing is left on the top, we just write a 1. And that is the same thing as b to the negative 2. So the way you get introduced to negative exponents is through quotient rule when your remainder of your bases is left in the denominator. Putting it all together, take a look at this example. Just to kind of stretch your wings a little bit, your coefficient is 3/15. We're going to go ahead and reduce our coefficient as a fraction, and 3/15 have a common factor of a 3. So 1/5 will be our simplified fraction. Then we're going to take a look at and find each of our common bases, our m's, our n's, and our p's. Handle them each separately and subtract. So I'm going to give you an easy way to do so, but I simply say find my larger one minus my smaller one. 9 minus 5 is 4, and I'm going to place my base where my larger exponent is, because that's where the leftover is going to be. Once I handle that, I'm going to go on to my n's. When they cancel out, it doesn't become a 0. Remember that anything divided by itself is a 1. So we simply don't put anything. Now we're going down to our p's. Our larger one is an 8. 8 minus 4 is 4, and I'm left with 4. So simplifying without writing down the 1, we have p to the 4th over 5m to the 4th. And so with that, we conclude our product and our quotient rule. Hope that